afternoon, everyone. So I'm Saurabh Deshpande, and today I will be talking about data-driven surgical simulations. In 2018, I had to undergo an urgent shoulder repair surgery, and I clearly remember the stress I took in order to find a suitable surgeon. I lived in one of the biggest cities in India with a population of 6 million, but there were barely 10 recommended surgeons. I was fortunate enough to get treated by one of them, but not everyone around the world is. Surgery is not accessible to everyone, and it is the fact. There are several studies and scientific surveys which claim the fact that there is going to be a definite shortage of surgeons by this decade. The ongoing pandemic has already showed us that our healthcare system is highly flawed. I can add on, in 2016, researchers from University of Johns Hopkins, they analyzed the death rate data over 8 years and found out that medical errors were the third leading cause of death in the United States. And I can go on and go on. All these factors, they keep me in very responsible shoes to conduct research on surgical simulations. Imagine a scenario. You're going for that long-awaited post-COVID era vacation. Would you like to take your flight with newbie pilot? Maybe not, but thankfully, we know that pilots are trained on flight simulators for long hours, exposing and preparing them for the exact same experiences of the real flight. Why can't we do same for the surgeries? And the answer is yes, this is what my research is all about. But unfortunately, surgical simulations are not as straightforward as flight simulations. And this can be attributed to two main factors. First, the complex nonlinear material laws governed by the soft tissues. And the second and the most important, every single patient shows a different behavior. This is because of differences in anatomy, material properties associated. And that is where, my friend, the term data-driven comes into the picture. So we take patient-specific data and build a digital twin for the same, as you can see on the other side. And now doctors are trained on this digital twin. This technology, when combined with pressure sensing devices, such as haptic devices, doctors can experience the sense of touch without even touching a real patient. This will immensely help in efficient planning of patient-specific surgeries. And to go one step further, this technology will help that remotely located patient who would otherwise lose his or her precise life because of lack of immediate treatment. So as a part of my PhD, I am planting seeds to this long-term vision. I have developed a deep learning model which can accurately predict the nonlinear deformations of soft bodies when applied with external forces. And it does so in real time. Otherwise, it will not make sense to use it in context of real-time simulators. And secondly, I take care of the uncertainties associated because no real-world process and no real-world data comes noise-free. So currently, I have been working on developing Bayesian and geometric deep learning models in the context of surgical simulations, although I must say that these methodologies are immensely useful in a much wider scope of engineering applications. I would like to conclude my talk by saying I feel responsible and enthusiastic to work on this project because I truly feel that it has the potential to change the world positively by training many doctors and saving many more lives with time. Thank you.
Terrific. Thank you so much.